To solve the problem, we made a water wheel prototype to lift the bricks 15 centimeters, and we used the tap from the lab as the river. We used the base made of the bottom half of a plastic bottle, a skewer and plasticine to hold the water wheel in place, and string to tie the weight to the skewer, so as the wheel turned, it would wrap around the skewer. But how did that work scientifically? Now the explanation for the science behind the method. First of all, the water from the tap falls down on the blades of the water wheel, and the falling water will have kinetic energy. This kinetic energy of the moving water as it drops is transferred to the blades of the water wheel, which causes them to turn. This will then transfer kinetic energy to the wooden skewer, which turns as well, and then to the string, which causes it to wrap around the skewer. Lastly, the load is lifted upwards due to the shortening length of string. This is how the kinetic energy of the water is used to overcome the gravitational force that acts on the load in order to lift it up. The larger the surface area of the wheel blades, the more water will come into contact with each blade. Thus, increasing the size or number of the wheel blades will also increase the amount of kinetic energy transferred from the falling water to the blades, the wooden skewer, the string, and then the load, and help lift it up at a quicker speed. We designed a water wheel so that the blades were as large as possible to allow optimum contact with the water while still being able to fit in the constraints of the base.
Created using Powtoon.